Great. So now that we've looked at the period and amplitude idea with these graphs, we can go through and we can kind of see exactly what that looks like in graph form. So the first sketch here in example 4 is y equals negative sine x. I want to look at the idea that in this problem I want to find the period and the amplitude. Those two things are the things that we're adding to our sketch so far. There will be more. We will be adding more things to this, but right now I just want to know how many times or how far does this graph go, and then I want to know how high does it go as well, the amplitude. So how far does one of these sine graphs or one of these cosine graphs fit, and then the amplitude, how high or low does it go? Well, the amplitude, if you remember, was the absolute value of a, and a is the number that's in front of a sine graph, so this would be y equals a of sine bx. And so the number in front of that graph is a -1, so I've got the absolute value of -1, which is 1. So this graph goes up 1 and it goes down 1. It has an amplitude of 1. It starts at the origin, because I didn't do anything else with it, and then it goes up 1 and down 1. The period, if you remember, was given by the expression 2 pi divided by b. And so in this case, I have 2 pi divided by the number in front of the x is a 1, which is just 2 pi. And so that means that in 2 pi, that's going to be one cycle or one frequency of the sine graph, which means that I want a few other things in between here. I want halfway between where it starts and where it ends. So the starting point is over here at 0. The ending point is at 2 pi. So halfway in between there is at pi. Okay, so I need that point. I also need halfway in between those, because the sine graph goes up and comes back down and goes back up again. And so I need those places that this goes in between those. So I need to take and cut both of these in half as well. Again, when we look at this, we're just sketching, and so you don't necessarily have to have those pieces of information in terms of like what they actually are, but it would be nice to have those. And so I've got 0 and pi. Halfway between 0 and pi is pi over 2. I've got pi and 2 pi, so that's 1 pi and 2 pi. So halfway between those, well, would be add those together. 1 pi plus 2 pi is 3 pi. Divided by 2 gives me 3 pi over 2. That's the average, halfway in between. Okay, 3 pi divided by 2. And so now I've got everything that I need in order to sketch this. I'm going to plug my points in. I start at 0. And I end at 2 pi. I didn't move this graph up or left or right or anything, so that's how my sine graph looks. Halfway in between there, it also crosses the x-axis. But the difference in this problem is that I've got a negative in front, and we know that a negative in front means that this graph is going to go down first, then come back up, and then go up and come back down again. So the graph's actually going to end up looking something like this. Okay, so I've got a negative sign of x. Good. And as we keep going, the things that are important to us are the period and amplitude, but we also need those x-intercept places. So this is the same sine graph that we just graphed in the last video, except that it goes down instead of up. So on this cosine, I've got 3 cosine x. So this is going to look like a normal cosine. There's no negative in front, but it does have a 3 in front. So when I look at the period of this, the period is still going to be 2 pi divided by b. And I look at the amplitude of this. The amplitude is still going to be the absolute value of a. So the a in front is a 3. So I've got the absolute value of 3, which is 3. And so this is going to go up 3, 1, 2, 3. And it's going to go down 3 to -3. The period is going to be 2 pi divided by the number in front of the x, which is a 1, which gives me 2 pi. And so this is going to start at 0, and it's going to end at 2 pi, just like the last sine graph did. I didn't do anything to the period. It's going to look almost exactly the same as the original cosine parent graph, except that it's got a different amplitude. It's got an amplitude of 3 instead of 1. But the things that I need on here are the important points. I've got halfway in between there, halfway in between those. Okay, so I've got pi over 2 and 3 pi over 2. Same problem that I just had on the last one. Now, a cosine graph is a little bit different than a sine graph. Instead of starting at the origin, it starts at the top of its amplitude on the y-axis. And so ways that I could get that is that I could plug numbers in. You can always plug numbers in. So I can do 3 cosine of 0. Well, the cosine of 0 is equal to 1, and so that's 3 times 1, which is 3. So x equals 0, the y value is equal to 3. That gets me this point right here. I could keep going, and I could keep plugging in the pi over 2, and I could plug in a pi, and I could do all of those things. But it becomes better for us to, in sketching a graph, it becomes better for us to know what happens as opposed to plugging these into the calculator. But you could do that. I could plug in the pi over 2 and find out what value that is. So cosine of pi over 2 is 0. So 3 times 0 is 0. And so this is at 0. Okay, I could go and I could keep going with this. And I'll do one more. I could plug in the cosine of pi. So I get 3 times the cosine of pi. And all of the cosine numbers can either come from your calculator or they can come from your unit circle. 3 times -1 is -3, so we're down here at -3. If you kept going with that, this is the way that your graph ends up looking. It's a cosine graph that looks like this. Okay. It has an amplitude of 3. It's a regular cosine graph from 0 to 2 pi, except that it goes up 3 and down 3 instead of up 1 and down 1. In the next example here, the things again that we want, the period, still the same way to figure it out. The amplitude, still the same way to figure it out. So in this case, I've got absolute value of a, so that's the absolute value of the number in front, which is a 4. Now we got 2 pi divided by the b. Well, this time the b, the number in front of the x, is a pi. And so the pi's are going to cancel out. And my period is 2. So I've got an amplitude of 4. 1, 2, 3, 4. Goes down to -4 and up to 4. I've got a period of 2. Okay, and so it goes from the origin, because I didn't move it left or right at all. And so it starts at 0 and it goes to 2. Well, halfway in between 2 is 1. Halfway in between 0 and 1 is 1/2. Halfway in between 1 and 2 is 1.5, okay, which I'm going to write as 3/2. Add 1 and 2 to get 3 and divide by 2. So it's the same points as I had before. I had pi over 2, pi, 3 pi over 2, and 2 pi, except it's just the coefficients in front of that because I dropped off the pi part. Okay, the pi canceled out, and I am not going to 6.28, which is 2 pi. I'm only going to the number 2 because I divided by the pi part. And so my one sine graph will fit in here. And again, you can always plug in these numbers. So if you plug in 4 sine pi of 1/2, okay, you can figure out what that value is. But again, if you are going through and doing that, I guess we probably could plug in the 0 first. Gives me a sine of 0, 4 times the sine of 0, which is 1. 4 times 1 is 4, so that's not true. Sine of 0 is 0. 4 times 0 is 0. So I'm down here at the origin. And sine of 0, again, can come from our unit circle. Here's a quick shot at that. The sine value is right here. Sine of 0 is 0. Okay, so your calculator would have given you that too, but I just wanted to make sure you knew I wasn't making these numbers up. They came from the unit circle too. So you can go ahead and keep plugging in the numbers, but this is going to look like a normal sine graph. It's going to go up. It's going to come back down. And it's going to keep going forever in both directions. Differences, it goes up 4 and down 4, and it didn't go from 0 to 2 pi, it only went from 0 to 2. So here's the last one. Let's do this one in black again. So things that I want are the period and the amplitude. 2 pi divided by b, the number in front of the x value is actually a 1/3, so I get 2 pi divided by 1/3. Well, what happens when I divide by 1/3? Let's go down here, 2 pi divide by 1/3. We did this work with square roots. I want to leave the first one the same and flip and multiply, which gives me 6 pi. So the period is actually 6 pi. Okay, so cosine, I didn't move it at all, so cosine starts at 0, and this time it goes one complete frequency, one complete revolution, one complete time around the circle in 6 pi. And I can do halfway in between that. Halfway in between 6 pi is 3 pi. Halfway in between 0 and 3 pi is 1.5 pi, okay, which is 3 pi over 2. And halfway in between 6 pi and 3 pi, again, if I look at the way that I'm doing this, an average 3 pi plus 6 pi gives me 9 pi. 9 pi divided by 2 is going to give me the average, so I get 9 pi divided by 2. The amplitude, I still need to do the amplitude, is the absolute value of the A value, which is absolute value of -2, which is 2. So this goes up 2 and down 2. It's a cosine, and so cosine actually starts up at at this point up here in normal situations. However, it's a negative, and so that negative causes us to not start up there. It causes us to actually start down here. Okay, so that's important to know, is that on the sine value, when I had that negative in front, nothing really happened because I start at the origin, and so when I flip upside down the origin, that's not the part that changes. It stays exactly the same. And you could do that too with this 3 pi over 2, because cosine is going to go through 3 pi over 2 and give me cosine of 3 pi over 2 divided by 3, which is cosine of pi over 2, which is a 0. So I get -2 times 0, doesn't do anything. Okay, it still stays at 0. But the graph has to flip upside down, and so what ends up happening is that it goes at the starting point, it starts at -2, and then it goes up. And so then at 3 pi, I'm at 2. At 9 pi over 2, I'm at 0. And at 6 pi, I'm back down at -2. Okay, so this graph ends up looking like this. And so some intricate things about this, beyond the amplitude and period, is what happens when you flip the graph upside down with that negative out in front. With a sine graph, it doesn't change where it starts, but it changes the other points. With the cosine graph, it changes where it starts. It actually starts down at -2. And again, you could plug these numbers in. So if I did that 0, 1, I get -2 times the cosine of 0. Well, the cosine of 0 is 1, so it's -2 times 1, which is -2. That's the point where it starts. So go through and get used to plugging these in, plugging these values in, getting values back. You should end up with nice numbers as far as the numbers that we're plugging in. And if you don't, then you need to look at the numbers that you've created for these intervals. But that's the graphing. That's as far as we're going to go on graphing at this point. We will go farther, but get used to the idea of what these graphs look like.